Hey everybody, I hope you're hearing me all right. Do let me know in the chat if there's any issues with the sound. So we're going to take a look at the GPT-4 Scientist. Let's just get to the fun part. Let's run it and then let's talk about it. There's a few different ways to run it. You can start with custom knowledge. We're going to talk about all of that, or from URLs. Let's go with custom knowledge. So it starts generating, it starts extracting essential information at first as a Python list and writes it right here. The custom knowledge that we have is just some stuff that I pasted from, hey Monty, welcome, from some GitHub repositories. I believe first one is the GPT engineer, and then I have repo to text. And I believe that, and one more, Aider. So it's in its first run, it's looking at the first item, the first GitHub repository, extracts the knowledge, and after that gives generates an idea based on that. And in the second run, it adds the second element from the list, and the third one. And then if there is another one, it will do that, and it will generate an idea for each iteration. And it accumulates knowledge by going over each. It can also do Wikipedia articles and arXiv. As you see on the fourth one, it's actually talking about GPT engineer, Aider, repo to text. Let's take a look at its ideas. First one was, given the understanding of AI adaptability, code generation, and persistence in GPT engineer, a novel idea could be developing AI project management system. This system would act as an intermediary between coders and their workloads based on the given user experience and the concept of high-level prompting. The project management system would use the prompts as tasks. So this first one is based on only the first item, which is in our custom knowledge, the GPT engineer. And the second one is based on the first two. Here it says developing an AI acts as a virtual assistant developer named GPT Developer Assistant. The third one includes Aider as well, a groundbreaking tool that blends capabilities of Aider. Okay, so this is how it works in a nutshell. And when it's done, it prints out a statement. Let's run it again, this time with some URL list. See, I have some Wikipedia URLs in the URL list that text. So it's going to use these URLs and extract its text. We are using only the first so many words. We'll talk about the code. By the way, we are using function calling. So there's some really interesting ideas here. Anyway, when we run this, it's going to ask us, this time you're going to choose URLs and not custom knowledge. And then if we have already done this process before, let's say we've already run and extracted the information from these, you can rerun it, or I mean, you want to rerun it if you change the URLs, right? So it asks us if you want to use existing knowledge, because if you extract it once, you don't want to extract twice, right? And I'm going to say yes this time. Actually, let's say no, so we'll see what happens. See, it's extracting content from Wikipedia, and then it starts its process. The first article is music theory, color theory, then comes next. And the third one is a mathematical concept called Capricorn's constant. So I was trying to kind of combine different, completely disparate things together to see if it would create ideas based on that. And as a matter of fact, it does pretty good. It made me surprised a few times. Okay, it generated the first idea. It overwrites this file. See, it says, considering the information provided, a novel idea could be a development of a universal music learning application that uses artificial intelligence and machine learning. This application will teach music theory across different cultures and historical perspectives, enabling users to learn about diverse musical notation, pitch systems, scales, tuning. So it goes on to explain quite a lot of stuff. A versatile AI tutor capable of adapting teaching style. So this knowledge, this idea is generated only looking at this. And the second one, it will include the color theory as well. Okay, it has extracted all the essential knowledge out of those, and it's doing it a third time, this time including the Kappa-Kar's constant. So the second one says, considering the principles of music theory and color theory, a new form of synthetic art representation could be developed, musical color theory. Effectively, this new theory would aim to associate each musical note with a specific color from the color theory principles based on their frequency and emotional impact. This musical color theory could revolutionize the way we experience music and art, given a color equivalent of representation for every piece of music played. For example, warmer colors could be associated with higher pitch notes. So it goes on. That's interesting. And the third one includes the knowledge from the mathematical constant called Kappa-Kar, which is really interesting. You take any 4-digit number and you apply this mathematical operation to it, and every 4-digit number ends up ending being 6174. So let's see what it generated for that. Given the knowledge of music theory or color theory, as well as mathematical concept of Kappa-Kar's constant. So this is interesting, right? I mean, Kappa-Kar's constant is not exactly related to music theory and color theory. An original idea could be to create a unified art and science exploration platform. This platform can not only analyze and teach those theories, but also allow users to explore their interconnectedness in an interactive way. For example, a user could input a piece of music. The platform could analyze its structure and generate a color scheme based on the identified keys and rhythms, then assign these colors based on the proportions defined in color theory principles, resulting in a unique visual representation of the music. Furthermore, the platform could incorporate Kappa-Kar's routine as an interactive educational tool within the platform, demonstrating how numbers can be iterated into a constant figure. Actually, when I did this earlier, it came out with a really interesting idea, which was to actually convert notes into 4-digit numbers and apply the Kappa-Kar's algorithm on it, and eventually change the tunes accordingly, right? So anyway, so this is one. Let's do another. I have some examples here, and then we'll start talking more about the code. Also, feel free to suggest some URLs. You can paste them in the chat. This works with URLs, right? We can either archive paper URLs or Wikipedia articles. I have something here. Where is it? Example URLs. For example, I have the LLM paper URL. So these four, I'm just going to copy this into URL list. It works out of this URL list.txt file. Put it here. These are the papers. These are the famous papers, right? The attention is all you need. Language models are few shot learners. Textbooks are all you need. This is a new one. And long former, most of you must have heard of. I see some messages. Let me respond to you guys. Let me run this thought. So we have now put this here. We're going to run the auto scientist. Do you want to use custom knowledge? No, we're going to pick URLs by typing U. Do you want to use existing knowledge? No. And now extracting content from arXiv. This is a bit slower. Novel, how many pages or words? No, it's pretty short. I guess you can prompt it to give more explanatory responses. See, the prompt is this. You can read it. You're a novel knowledge generating intelligence. Your goal is to generate novel knowledge, giving some information. So we iteratively give it the information. So here it's extracting essential knowledge from attention is all you need paper, then generates a novel idea, hopefully. Then goes on to add the second paper on top of it. Then generates another one, and the third one, and the fourth one. So I did something interesting with the prompting this time. As you see, we have the system message, which we start with, right? Messages starts with the system message. And then I ask it, are you ready? I've seen other people do it too. So instead of trying to, if you ever try to use like few shot examples, usually you always try to kind of cram it into a system message or user message. Instead, you can actually generate these pre-decided conversation. So then after the system message, I ask, are you ready? And then I actually define the assistant's response. Here it says, I'm ready. Please provide me with some new knowledge. I will extract the essential information out of these and list them while combining the new information with the past extracted essential information to extract a combined essential information list. This was important, and it sometimes still fails. We are using GPT-4, by the way, because we want to keep adding to this knowledge base, right? So if you look at this, this is its first knowledge extraction from attention is all you need. The second one has grown because it included language models or few-shot learners. And in the third one, it included textbooks somewhere over here. This is a Python list. Textbooks are all you need. And then the fourth one, it hasn't done that yet. And it has generated yeah, sometimes it's not supposed to append, but it sometimes ends up appending. So it didn't do it here. I'm not sure why that happens. Anyway, from the essential information see, this is pretty long. Attention is all you need paper. It becomes clear that the transformer model has revolutionized sequence transduction models with its novel use of solely attention mechanisms. Here is a novel idea for extension of this work. The attention mechanism of the transformer model could be potentially harnessed for applications beyond language translation. One unexplored area is the domain of signal processing. Consider audio signals, for instance. Converting audio signals to a symbolic representation, much like a language, then go back to audio signals. An approach using transformer models could potentially benefit from the model's ability to handle long-range dependencies. So it can get pretty interesting, pretty complicated. So would this really work? Honestly, I don't know, but maybe if a true PhD AI engineer were to listen to this, they might get some inspiration out of it. The second one includes the first two papers, right? Considering adaptive language learning AI, an artificial intelligence model capable of learning the structural and semantic nuances of any new language upon exposure to a few examples of the text in that language. Leveraging the self-attention mechanism of the transformer model, this AI could understand the contextual relevance of the words and phrases. So it's really interesting, and I'll just show this too. I did this experiment. I gave it NVIDIA, Wikipedia, and Pyramids Wikipedia, which talks about pyramid structures around the world. And it came up with this. See, given NVIDIA's expertise in processing complex data and architectural characteristics of the pyramid, my novel knowledge proposition is the potential application of pyramid architecture in designing and organizing data centers. See, it says, first of all, it's sturdy. Data service can be organized into layers with most used and critical data at the bottom, less frequently used at the top, improving data access efficiency, reduce energy consumption. Additionally, the heat from the servers at the base could naturally rise to drive a convective cooling process for the upper tiers. This way, the architecture of the past could enhance the sustainable data technology of the future. So it's pretty interesting. Oh, okay. Yeah, I'll zoom in. Yeah, so yes, we did jump right in, right? So Auto Scientist takes a look at this URL list, okay, and goes and extracts the text out of each link. These can also be Wikipedia articles. And then extracts, I'll show you here, and then extracts the first 2,000 words and first 2,000 words and the first 1,200 words for arXiv papers, because scientific papers have these complex words which end up being a lot of token. About 1,200 words from arXiv actually ends up being equal to 2,000 words from a Wikipedia article. So once we've done that, we send it to GPT-4 along with this prompt. I'll just put it right here, and this kind of like a few-shotting it. Okay, and then we add the content, and then it extracts essential information out of here, in this case from like the paper. Attention is all you need. As you see, it lists, I'll actually show it right here. it lists what it considers is the essential information one by one. And after that time, we ask it to try to generate the original and novel idea based on that knowledge. And then we grow its knowledge base one by one by adding the additional information from the next URL. And we are using function calling to do that. This is the function description. I mean, we are not using a function. We are just using the function definition to return structured information, such as this Python list of extracted essential knowledge. Also the string of novel idea output, if you look here, takes in essential information and a novel idea Boolean. So it first decides if it's going to say true or false to novel idea Boolean, meaning if it's going to generate novel idea or not. And then if it's so, it generates a novel idea output. Otherwise, it combines essential information from the given context. So the ordering of this was important. We'll talk more in detail about this, because my original idea, and here I have some files, was to continue giving it knowledge and then expecting it to come up with a new idea when it's ready. That's why I originally came up with the novel idea Boolean, whether you have a novel idea or not. So I was hoping I would just continue giving it knowledge and it would decide, yes, now I have a novel idea, and set this to true. In my experiments, that didn't happen, so I am actually forcing it, the novel idea Boolean, to be true. I am not actually forcing it, but kind of tempting it right here to show you. See, every so often in the loop, which we'll look at, I'm saying you must generate a breakthrough novel original idea at this time. When we send this message as the user message, then it sets its novel idea to true. Then it outputs novel idea output, and it does not output essential information for that run. This way, actually, we're keeping track of, we are not doing any token counting or anything like that, but by doing that, we are reducing the amount of tokens it takes, because this can get expensive, right? We have 4 URLs. A single run of this might cost 50 cents to $1. If you have more, it can cost more. I spent $30 yesterday trying to get this working. We also have a nice little message reduction system. If you like, let's run this in debug and see what's going on. Let me put some check marks. So we have functions. I tried to separate everything in the functions: process idea. This is just to ask the user for. Let me put a breakpoint to each one. Okay, that's it, right? And previous stuff is just setting the model and the messages. Okay, so if we run this like that, let's also maybe pick a new one. Example URLs, like I have philosopher URLs, music. Look, let's pick these Wikipedia music URLs. Put it here, so we'll work with this. So let's run it in debug. So we're going to do line by line execution, so we'll see what's happening. So do you want to use custom knowledge? We're going to say URLs. So now we are here. We're going to skip that. So because we did U, then if it checks if the knowledge from urls.py exists. If it does, then asks if you want to use existing knowledge, which is saved here to this file automatically as a list, or if you want to generate new ones. Since we have new URLs, we're going to say we don't want to work with existing knowledge. So we're going to say no here. I can zoom in. Is that better? Let me know if you like to zoom in further. Do you want to use existing knowledge? We're going to say no, because we're going to extract new information from new URLs. So because we said no, we're going to run this extract content function. Extract content is going to print this extract content from URL. And it checks if arXiv or Wikipedia org is in the URL. And then runs the extract from Wikipedia, because these are Wikipedia articles. It uses requests to get the response. So this is our response object. Then we use beautiful soup to parse it. This is our soup. And then we find all paragraph elements. And then we go over the paragraph elements. Let me run this. And our text is now populated with the rock music genres Wikipedia article. It's quite long. And then we do, so there's some, ends up being some non-alphanumeric characters for Wikipedia articles. We're just trying to remove it with regex. And then we are getting only the first 2,000 words. I mean, we're just using the split, whatever. This ends up being about 2,000, ends up being anywhere from 2,000 to 2,500 tokens. So we're doing that. So we're going to do that for each one. And we are printing it. Let's do the next one. And when we do these, we are adding it to this file, the knowledge from URLs. Well, it hasn't written it yet. Yeah, here it's going to write knowledge. For item and knowledge, it's going to write all of it. So then we enter the main loop, right? Which we are running with a while. Let's go back to that file. See, it has now the rock. And I am adding 4 new lines. And then we have the hip hop. And we have the bluegrass. And I put a new age because I thought they're kind of different. You know, let's see what it comes up with. So we enter the loop. Here we check the messages. See, this is currently the our priming messages, right? Messages only include right now the system message, and when we ask, are you ready, automatically in the program, and then its answer, which we did right here. So this was our system message. We are starting with that, and then we ask, are you ready, and then we make it give an answer. So this is the prime it. You can also use this technique. Yeah, you can, I mean, code interpret, you could, I mean, essentially you can define in the function. So DSL was asking, how about using it with code interpreter so it reads the files? I mean, you can add a function which reads files, but I mean, since you know what you're going to do, it's better to programmatically do it because you're introducing additional variability. You know, if the GPT is going to choose to use that function or not. But anyway, so this is our messages to begin with. If we come back to the while loop, we are checking. I mean, obviously, we only want to go for as much of. We only want to go for the amount of knowledge that we have. That's why we're checking here, and then we're going to append just the new knowledge, okay? Because we already primed it to do what, and then process idea. Is going to call this idea generation function with new knowledge modeled in the messages, which is just our call to OpenAI. And before we go, see, this is the function definition before we continue. So we are defining a function, but we don't have any function that's called essential information extraction. We are only defining this function for it to return to us the type of structured data that we're looking for. So this is how I figured I'd do it. Originally, the combined essential information extraction list was at the top. So if you looked at function calling, you have to kind of follow the schema, but you can actually be creative with it. So there's a name. The description of this is takes in essential information. So essential information here is what we have extracted from either a Wikipedia article or arXiv paper, or what we have put in as custom information. See, this is a bit this is a bit like it might be difficult to wrap your mind around this, because this function description is not a prompt exactly to the, I mean, it is a prompt to the GPT, but it has to define what the supposed function is supposed to do. So the function takes in essential information and a novel idea Boolean. If the novel idea is true, the novel idea output should be provided, and combined essential information extraction list is ignored. If novel idea is false, combined essential information extraction list should be provided. Why? This is solely for the purpose of saving tokens. When we give this to GPT, the combined essential information extraction, if we go back, is when it does this. See, it says novel idea is false because it doesn't have a novel idea. Then it does not generate novel idea output, but it still generates the key for the JSON object. And then it starts combine essential information here. This was what I did earlier about the Soren Kierkegaard philosopher. So it takes in the article and it generates, okay, this is essential information. This is essential information, right? It creates a Python list of what it considers essential information. And in the second round, because we ask it, and because in the second round we say now you must generate essential a novel idea, then it sets itself, it does it itself. It sets novel idea to true, and it outputs a novel idea, and it does not output combined essential information extraction list. So when you're doing function definitions, pay attention to which comes first. So originally I had this up here. Okay, let me just show you for demonstration. This was here. If this is here, this is what the model is going to output first. Now you see, it has no way of knowing what it's going to do with the novel idea Boolean. It doesn't know yet if it's going to output novel idea true or false. So that's why I replaced them. Go back, yeah. And make sure that I have the novel idea Boolean at first, so then it'll know what it's outputting for novel idea, because as we saw here, it's first outputting that, see, in order. Novel idea true, novel idea output, then it's outputting novel idea output. Because it has defined novel idea output to true, and we told it not to output combined essential information extract list, then it leaves that blank. However, if we go to one earlier, here it said novel idea false, and then it left novel idea output false, because we don't want it to output novel idea. We just, in this case, we only wanted to extract the essential information. Critical for being hyperlinked pattern. Yeah, no, could try with the code interpreter. You could give the, you'd have to download the URLs, or you could give the URLs to code interpreter. See what it does, right? So this is how it works. And we have the description, right? Novel idea is of type Boolean, whether you have a novel idea or not. Novel idea output is a string. Novel idea generated by you if novel idea is true. Otherwise, empty string. Combined essential information extraction list is an array. When you're trying to define lists or arrays, you do have to choose array. You can't say list, you'll get an error. And then you can't do it like this. So you say type string and then immediately description. But if you go with array, you have to specify what the items are going to be. Here, in this case, we want strings and the description of each string. Then is essential information extracted from the given knowledge. Provide this only when novel idea is false. Otherwise, empty list. We only want this when the novel idea generation is false. The reasoning behind it is that we just don't want to waste tokens. That's it. We don't want it to generate novel idea and then repeat itself. Okay. So we're just entering the idea generation. So we have set our prompt. We have our function definition, and we are also doing streaming responses with function calling. we'll talk about it. We'll get there. So we're just setting this up. It's going to go over each and every one of it. Oh, and let's talk about here too. So take a look at this. Right? You do have to define this required. You do have to have this. If you don't have this, then OpenAI is going to give you an error. We are saying novel idea is required. Novel idea output is required. I mean, oh, and combine essential information extractions. We're saying each and every one of them is required, even though we are setting it to return an empty string in the cases. We do have to say it's required because if we want to parse this with JSON, we need to be able to parse all three of them. I've come up with a method actually, which even if the JSON parsing doesn't work, it tries to extract that information anyway, because I mean, Python having all the utilities like string with strings or regex, you can still extract that. We're going to talk about that here in a second. So, but here, in function call, so this is a parameter that goes directly to OpenAI, right? Model messages, we set streaming to true. Functions is a list, and a function call is a parameter. We are forcing it to call this function, by the way, so it will never respond in this case with content. Let me delete this real quick. So this is all you would need in a normal case, okay? You say function call, the name is an object, essential information extraction, which is the name of the function you define in your functions. We have a single function, okay, which takes in supposedly we don't have a function, but we have a function definition, which supposedly takes in three arguments: one novel idea boolean, novel idea output, and an array of combined essential information. When we say here in the function call, like this, when we define the function, then we force GPT to always do a function call. Essentially, if you look at the output, it'll say content null. Now there are other, you can also set this to auto, like this, with all small letters. If you set it to auto, then you're allowing GPT to choose, if you have multiple functions, which function to use, which function call to make. We have a single function in this case, but I made another video on multiple functions. I'll show you it here in a moment. Or to respond is with content, right? So auto allows GPT to decide, and you can also set this to none with in between quotes, okay? If you set it to none, then it will never make a function call. It will always respond like regularly, like with content. Let me demonstrate this further. Do let me know if I'm talking too much on this, by the way, but if we go to GPT's documentation, right? If you go to chat completions, the regular chat completion is like this. See, you get content. See, you get content. That's what I mean by responding with content, and you extract it like this, right? You don't do that with function calling. If you go to function calling, let me see if the, yeah. See here, finish reason. The way you extract, somewhere over here. So you extract a message, and then you check for a function call, and you have to get the args, and see here you most of the time you're trying to use JSON to extract it. But if I'm going to talk about a way where JSON fails, so that's what I was meaning. So there's like the content response, there's the function call response, and with function call response you can also have multiple functions here. Let me just zoom out real quick so you can see, like, just this how it looks. It's functions is a list, and it's a single function in this case, but you can have multiple functions, and auto will allow it to choose. Anyway, okay, that's enough of that. Okay, so let's run it. So we are doing streaming responses. So this is interesting because it was difficult to do streaming responses with function calling, and we are forcing it to call this function every time. Oh, actually, I wanted to talk about one more thing. You see, all you would need is just the name of the function, but I added arguments as well. It doesn't throw an error, so you can be a little creative. OpenAI doesn't specify what's allowed and what's not, but you can add additional things to it. Like you can add here like optional. You can define an optional parameter or things like that. Say optional properties, for example. It'll accept that. You can try to give as much information as necessary, perhaps. Here I'm doing that. Combine essential information. It's empty, I'm saying, so that this is a way for me to try to get it to, okay, well, it can be empty. Novel idea starts at false, and novel idea output is empty. Anyway, so we are because we're going to have streaming responses, we're going to receive everything chunk by chunk. We are initializing an empty string, and then response is a generator object, so we loop over it. Essentially, delta is what you're trying to get out of those chunks, and you want to get the function call. We know for sure that each and every one of them is going to have function call in it. Why? Because we did this, right? We did this. When you do that, when you give the name of the function that you've defined, it will always call that function. So we are certain this is going to happen. Then we get the delta as chunk, and then response then is the function calls arguments. Okay, and this is the chunk. And we append it to responses one by one. We print each one of them so we can see them on the terminal. And once this entire process for loop completes, then we have our full response. Then we can append it. We can return that response. Okay. So let's run it. Oh, yeah. Since we started it, we didn't get the secrets. Chunks had already arrived. Anyway, moving on, we enter the process idea. So here, the process idea function is going to try to extract essential information, novel idea, and novel idea output using JSON. Okay, so this is the recommended way. This is all the examples you'll see anywhere will have this, including in OpenAI documentation. But you also, if you use function calling enough, you're going to realize this fails. The reason why it fails, especially with code, it'll fail. Especially with JavaScript code, it'll fail. Probably with CSS code as well. Because the reason is, especially with 3.5 Turbo, you're going to fail sometimes because it just doesn't return a proper format. Because let me try to find an example output. I wish. The example output of a function call is a JSON object, right? And arguments are in a JSON format. We're trying to load it, but then because it has those curly braces, and you have to escape the inner curly braces and stuff like that, and just whatever GPT returns sometimes just doesn't satisfy the criteria which JSON.loads can deal with. But we're going to try to do it. So we have our response. Let's go. Oh, now we're actually going to the second one. Let me just talk about this real quick, and then we'll continue because we are still processing information. We're going to try to extract essential information from the combined essential information list key from the response object, novel idea, the same way, novel idea output. And then we are going to append that response back to, because this is the assistance response. You have to do this yourself. Function calls response. Obviously, you want it to be added back to messages to give feedback to GPT. Okay, and then we check if there is a novel idea, then we actually write it to a file, print it to terminal. Okay, and also we write the combined essential information extraction list. This is how we are getting these. But so because we are using a try except block, If this JSON.loads fails to parse the response from the function call that we're making, then we're going to try to parse it with the regular good old-fashioned methods. For example, we can check for this. Look, pay attention that I have a single bracket, sorry, a single quote, and we are checking for this. Novel idea, true, because this is what it would return. Let's take a look. You see, novel, now, so it would return this. So it's returning this curly brackets, it's returning this, it's returning lowercase first letters for false and true. That's fine. So we check for that, and we make sure we convert response to lower, and then we split it, okay, and then we get the right element out of it, making sure that we extract it and we write it anyway. And then we append that response. I hope this made sense. You know, in the case of, yeah. So we're not, here in this case, we're not too worried about, we don't do anything about the rest of the stuff here because the novel idea is the most important thing. Okay? Yeah, going on. Let me see what's happening. Let's actually stop this and run it from scratch so we can see. So we talked about the code. Let's see how it's running. We are, for those of you who are new here, we are going to use this URLs to extract knowledge and create novel ideas about them. The URL list consists of the rock music, hip hop music, bluegrass, and new age genres. So we run this. It's going to ask us if you want to use custom knowledge or URLs. We want to use URLs. Do we want to use existing knowledge? We're going to say no, so that it will extract contents. It's doing that. And now you see, novel idea false. It's first extracting the information. Rock is a genre of popular music that originated from the Wikipedia article. We are using GPT-4. Actually, it's pretty fast. If you're using the API, literally, at least yesterday, the speed of 3.5 turbo and GPT-4 were the same, for me anyway. So it generated a novel idea. Let's pay attention. Again, novel idea was false. We got no novel idea output. We got combined essential information extraction list. In the second run, we were able to get novel idea to be true. In that case, we got a novel idea output, and combined essential information extraction list was empty. Yeah, it would. I think actually the first example, the very first example was GitHub repos. What I did was, for example, this is GPT engineer. I copied this part. I pasted it in the custom knowledge list. I'll show you how to do that. But you have to realize, I mean, there isn't a lot of descriptive stuff in repos a lot of times. That's what I realized doing this. You can give it straight up code. You can try that. We can maybe try it here in a little bit. Like, so I did that. I did it without URLs. I also got the, anyway, yeah. So I get a few of those. Anyway, so this is how it works. It's still continuing. And if you look at what it's writing as the extracted information, let me zoom out a little bit. So first one is rock. So it takes a look at the Wikipedia rock article and then generates some idea about it here. The idea is, the breakthrough idea could be to create a global rock genre that infuses rock music with the traditional music and instruments of various global cultures. This could be a new direction for rock music. And in the second one around, the JSON parsing must have failed, so we extracted it in a regular way. This includes the hip hop as well, so we are giving it now more information, hoping that it will come up with more creative ideas. And the second time around, it says continuous shift and evolution My new idea proposes the creation of a dynamic genre evolution model. This model would map the different musical styles, instruments, themes, and influences that are most prevalent at any given period. It would also predict future trends by examining. So he's proposing some machine learning model. And in the third one, we include rock, hip hop, plus bluegrass. And its third idea was it's suggesting a new genre of music, which fusion, cultural energies of three genres: rock, rebelliousness, hip hop, social commentary, and bluegrass's connection to roots. This could lead to creation of truly multicultural, diverse things. So, and the fourth one should also include novel idea. Yeah, fourth one. So sometimes it fails to, because you're still relying on GPT to accumulate this knowledge. Almost like 9 out of 10 times it works perfectly, but sometimes it forgets the previous knowledge. Okay, that's just a limitation right there. You can try to play with the prompt. We'll go back to the code again, but I just want to talk about how you can enter custom knowledge. So there's so the important thing is the URL underscore list.txt. This is where you put your URLs. It gets the URLs from this file. Let me close everything else. So I have a lot of files. Let me actually delete these. These are generated by the code. So the important files is autoscientist.py, custom knowledge underscore custom, which is just a list of knowledge. Make sure to enter, if you wanted to enter custom knowledge, okay, this is a list. Make sure to enter it with triple as a doc string, so there are no problems with if there's quotation marks in this thing that you're copying. So you asked if we could do it with GitHub repos. Yes, you can. I thought this would be a better approach to even inserting information from the terminal, because maybe you might want to think about it, like craft something that is really cool. Like you can really think about it is what I'm saying. So this is GPT Engineer's GitHub repo. I thought this part is the most defining part of it. I didn't want to get the usage. Yeah, this decision is yours. You can copy it, okay, and paste it in between doc strings like this, okay, and then comma. So you're creating a list. You can make as many spaces as you like, and then enter another one. Let's see, Aider. Just why do I go with Aider? Because it has some description. That's why. Now a lot of repos have good description. So copy that, for example, paste it here. Now we have two pieces of custom knowledge. Now if you run this, you can have as many as you like. It's just going to get more expensive. You're just going to use more tokens. That's it. You want to use custom knowledge. We say C, pay attention, C and U. We say C. So it starts with novel idea false, and it's going to examine this and try to come up with a novel idea. Okay, example URLs. We did this one. There's I have these philosopher URLs: Rene Descartes, Nietzsche, Spinoza. We can try this. Or also, so if you want to send me links. No, this code is available. By the way, this is at the $9 tier. Link is in the description. Right here. So it's already at Patreon. Oh, it looks terrible. Or maybe because I'm zoomed in. I'm not sure. And also, this is echohive.live, right? You can search all my videos, and we were talking about function calling. So if you go there and search for function calling, I have quite a few videos. The one I was talking about is this one, ChatGPT function calling stress test, where I automatically test 20 functions to see it was 100% accurate with that. You might want to take a look at that. This one talks about streaming responses. This one is dedicated entirely to how to do streaming responses. This one is really cool. This actually has all the examples from the OpenAI's cookbook repo. This is like the official. It includes all the code that is officially representative of when the function calling first came out. There's also this one. Yeah, take a look. It's echoive.live. Anyway, so we did give it the what did we do? Oh yeah, we did give it custom knowledge, right? So you just put your custom knowledge here, and it extracted this information, and its idea was this. Given the easy adaptability learning ability of GPT engineer, a novel idea can be create a domain-specific code generator tool. Leveraging this flexibility, users can train GPT engineer to understand their specific domain language, for instance, bioinformatics or aerospace, and generate code base customized for these domains. Okay, and as in the second one, it also included the aider, and this was its idea. This development of an AI-assisted immersive learning platform. This platform could combine features of both these tools, providing users with a learning trajectory that adapts to their individual style and pace. Let me just quickly look at the chat, see if I missed anything. Let's try it with code. Oh, yeah, let's try it. Okay. How about we give it its own code? Let's just try it with one and make sure. What is the problem? Oh, because see, I have the triple quotes here. Okay, this should, so we just give it one. So this is its own code. Make sure I save it. It's just going to overwrite these. I can delete them, but let me do it. So you can change the code to modify it to make better use. I mean, have better organization. It just writes it to working directory. So we want to use custom knowledge. Let's see. Utilizes OpenAI for novel idea generation. Implements this model. Code architecture. Let me close this. Code architecture follows a retry protocol with exponential backoff. Yeah, let's talk about that. I do. Content extraction capabilities include processing information from Wikipedia articles and arXiv papers. All allows users to specify source of knowledge, custom or URL. Uses beautiful soup and PyPDF for parsing web and PDF content. That's pretty cool. Maintains a list of messages to track dialogue history. True. Generates novel ideas and essential information in the form of a chat conversation. Ideas and essential information are stored in written to text files for reference. The AI model can be extended to include a learning mode and generating mode. In the learning mode, the model learns and extracts essential information over several iterations of content extraction from various sources. It builds an internal database of essential knowledge. In generating mode, it uses this learned database to generate novel ideas combining various aspects of the learned data. This way, the model can iterate between learning and generating stages. This is fantastic. This is actually what I did before, and I was thinking of improving in the. So, look, if you have, I mean, I think this works pretty well. I was thinking of this. Look, let's touch on this a little bit on this topic. First of all, just take a look. You're getting structured data. This extracted information is a list. Look, you can embed this, for example. You can put it in a database. You can, if you continue to use this system, you're going to accumulate more and more of these. Like in my testing yesterday, and then just in this video, I think I generated over 1,000 of these items for all kinds of different things. So you could store it, you could embed it, you could store it in a database, like I said. You could. My idea was, and I'm going to work on it, maybe making a future video, is to embed these, implement similarity search, and then chat with the auto scientist. Like, for example, because we're not really chatting at this point. This is just an automated system. You put in either custom knowledge or URL list, and it does the rest. But you could convert it. Maybe it'll do this, or maybe it'll have two modes, maybe like a chat mode with some vector DB, and whatever the user says extracts the information which was extracted as essential information. So whatever, there's a lot that can be done, you know. And I like its suggestion. And it wrote it here. What else did it say? This way, the model can iterate between learning and generating stages, progressively enriching its knowledge database. We can actually kind of do that here. Right here. See, we are checking. This is the stage at which we are extracting knowledge. If you were to set this to 2, for example, it'll skip the first article and it'll try to generate idea for every second iteration. Like here in this case, we have 4 URLs, right? Let's actually get the philosopher ones. Try something different. There's 6 of them. If you were to paste it here and set this to 2, then it's not going to generate an idea after the first URL. It's going to generate after the second, and for the 4th, and for the 6th one. So we are kind of actually implementing the idea that it generated. Run it. We want to use URLs. So say we want to use existing knowledge. No. What is existing knowledge? Existing knowledge from URLs. Okay, this file. Custom knowledge underscore custom is what you put in. Knowledge from URLs are generated automatically. If we were to say yes here, then we would be using this music one that we had generated. Okay, that's why we're going to say no here. And it's going to extract the contents of these philosophers. And then as we watch, see, the first one is Rene Descartes. Novel idea false. Yeah, I actually read a bit of Rene Descartes. He's definitely interesting. He's the guy who said, I think, therefore I am. You should pick that up. So I'm saying cogito ergo sum. I think, therefore I am. See, second time, novel idea is false. Okay? So now we're combining. So the first parts of the list is still Rene Descartes. GPT is doing all this on its own, by the way. And we're now in the middle, we're switching to Friedrich Nietzsche, the Zoroaster, Schopenhauer. I like Schopenhauer. Anyway, so now in the third time, novel idea is true because this is still the second iteration, and it's coming up with ideas based on Rene Descartes and Nietzsche. What does it say? And then now it's going to move on and it's going to include, who's the third one? That's going to include Spinoza. So we can read it. Drawn upon the philosophical insights of both Descartes and Nietzsche, we can propose a novel approach to understanding human cognition and self-awareness. This approach merges Descartes' cogito ergo sum, I think, therefore I am concept, the idea that one's existence is confirmed. The idea that one's existence is confirmed by the fact of one's thinking, with Nietzsche's concept of perspectivism, which asserts there are many different interpretations or perspectives of the same truth. The novel concept here is the perspective confirmed existence theory, asserting that the act of thinking from different perspectives and viewpoints confirms not just of one's existence, but enriches our self-understanding and place within the world. So it can get really interesting with philosophy. As you see in the third one, we have the Descartes, Nietzsche, and Spinoza. But we're not going to generate again, right? This was the third one. We're going on to the fourth one. This one will also include Johann Wolfgang von Goethe. Interesting, you know, Goethe, am I mistaken? Wasn't he the guy who, contemporary of Isaac Newton, and came up with a different but exact same calculus with different notations? Anyway, Goethe had a theory of light, actually. So Goethe was an author in essence. He was like what's called a person who just knew a lot of stuff. A polymath, right? Anyway, so after Goethe, so that's the fourth one, we do novel idea generation. And we put it right here. And we're continuing. Fifth one is going to include Immanuel Kant. And finally, Soren Kierkegaard. See, these are the characters that we are trying to remove. Because the article itself contains them too. With the re that we talked about earlier. Anyway, so then so this one includes Goethe as well. See, so this is pretty lengthy. So you can essentially limit it to every second iteration for idea generation, or even every third, or put it at 6, I believe. Shouldn't it be 5 though? No, it is, and just get one idea at the end. Leibniz, yeah, you're right. It was Leibniz. Sorry, yeah, kind of it wasn't Goethe, but Goethe did have a theory of light, which wasn't, you know, well taken. I guess it wasn't popular. What were oh yeah, you can modify the loop here to generate the idea whenever you like. I'm just gonna go back to 1. Because as long as we're spending all these tokens with GPT-4, we might as well spend a little bit extra and get an idea at every iteration, was my thinking. Because it's going to generate the second one anyway, right? Let's talk about the Tenacity. So why is this necessary? So there's Tenacity library, there is the backoff library. You can also implement your own custom backoffs. What these do is, if a function gets an error, see, you do have to wrap your OpenAI call in a function. What will happen is that if this function fails, like you get a rate limit error or something, or for any error whatsoever, then your application will crash. You can try to wrap it in a try and except block and try to do something yourself, but that's just going to get complicated. Tenacity does it automatically here. We are using exponential. You don't have to use exponential backoff. What this means is, if this function, meaning this call, fails for any reason, then it will try up to 5 times. Each time it's going to wait anywhere between 2 to 30 seconds. It starts with a random number, I believe. But until the 5th one, if all else fails, it's going to multiply that number by 2. That's why it's called exponential. So let's say the first time this failed, it'll wait, let's say, 2 seconds. Second time, if it fails, it'll wait this time 4 seconds to try this function again. And the third time, it'll wait 8 seconds, trying again, and 16 seconds, and eventually it will wait 32 seconds. And if it fails, then that's done. There's nothing we can do, but at least this will allow you to, get over some of the hurdles you run into sometimes. Like, you get a rate limit error, and sometimes you can truly hit the rate limit error, or something happens anyway. So Tenacity is great. You can actually find this at OpenAI's documentation. So if you go to rate limits, it talks. Check out OpenAI's documentation. They have a lot of cool stuff in it. You can see what your rate limits are. Number 1. Yeah, see, rate limits are for GPT 3.5 Turbo, you can make 3,500 requests per minute and 180,000 tokens per minute. If you reach this, you'll get a rate limit error. Actually, I reached this on this video. This one. No, not that one. Concurrent summaries video. Oh yeah, this video. We were in this video. I was trying to summarize 20 documents at the same time using concurrent features, and it seems like these limits are a lot. But if you're gonna build an application using async IO or concurrency, like you start hitting these limits pretty quickly. Or if you can request to get these increased, by the way. But I was using so see, for Turbo 06, it's only 90,000 tokens per minute. If you're making a concurrent call, 20 requests will do it, or 30 requests. Anyway, GPT-4 has 40,000 tokens per minute, so it's pretty low. Anyway, sorry, do let me know when I'm talking a lot about it, so something I shouldn't. Anyway, going down, see, it says, what are some steps I can take to mitigate this? There's a notebook. You can click on it. Takes you to OpenAI's cookbook, which is a lot of super cool examples about a bunch of stuff, by the way. Let me put this in the chat. It's the OpenAI cookbook. But anyway, so here it recommends Tenacity as number 1, as you see. It implements it a little bit differently, but more or less it's the same. I guess it says weight random exponential. So here it's not specifying a multiplier. Another library is backoff library. And another one is a manual implementation. That one is very verbose. So here we are using weight exponential, not random. So then I guess this one takes 2, starts with 2. So you could change these, like if we can make the first time weight 5, right? Okay, so let's talk about some of the other stuff that we're doing here in this code. So I'm just going to zoom out a little bit. Do let me know if you have trouble seeing. So the important things is here, we are setting a system message, and then we are, I don't want to call this few shotting it, but priming it. We are adding predefined conversation already. Like we give the system message, then we ask it, are you ready? And then we input this response with a reiteration of what it needs to do. And we talked about Tenacity. Yeah, function calling. Okay, the most important thing, I guess, one of the most important little things you can get out of this video is that if you're going to define a function with multiple arguments, function definition with multiple arguments, please be mindful of the order in which GPT is going to, the ordering of which, because GPT is going to output in this order. So you can play around with it in a lot of cool ways, okay? Like here, remember, we are first outputting the Boolean, which then affects if this is going to be outputted. So you can have those kind of mechanisms in place. So essentially, if null idea Boolean is true, then it does not output essential information. Right? We talked about the required function call can be this. Function call can be the name of the function call, or auto, or none. We are doing streaming responses. This is the print to the terminal. You have to initialize an empty string somehow, or something empty, then you So we get the chunk, and then we get the arguments out of the chunk, and that's what we say responses. This looks very unintuitive. It could have been done better anyway, but this works. This is a function on how to extract from Wikipedia. This is the part that removes those weird characters from the article. This one extracts it from arXiv. Pay attention that we're only getting the first so many words out of in these. You could modify this and make it so that it actually splits the document and summarizes it and returns it, so you can have access to the entire document. I just didn't want to really deal with it, especially with papers. By the way, visit the llmpapers.up.railway. Look, I found a lot of this app I built gave me the idea to actually do this, because I'm like, well, let's try to come up with something. So this app automatically summarizes every new paper that is published in arXiv, and it updates every hour. It's posted at Railway. You can visit it right now. Here, I'll put the link in the description. You can click on it, just read the summary, and then visit the full paper, right? But if you go to the paper, a lot of times papers are designed so that it has an abstract and an introduction, which really gives the essence of the situation. By the time it almost always have related work, so experiments. So getting the first few thousand words should be enough to understand what that paper is about, right? So this looks like a cool one. LLM assisted knowledge graph engineering. Anyway, this updates every hour, so you can keep up with LLM papers. So, like I said, you can actually modify it, devise a system where you actually use the entirety of the knowledge. Here, in this case, I'm using the first 2,000 from a Wikipedia article and the first 1,200 words, or whatever splits it into, usually words. The reason why arXiv is 1,200 is because scientific papers have these complex words which end up costing a lot of tokens. So 2,000 words in a Wikipedia article ends up being about the same as a 1,200 arXiv, which is interesting because we are using the exact same thing. See, dot split. Extract content just calls those functions. Write knowledge writes it to knowledge from urls.py file. URL list extracts the URLs from the URL list.txt file. And then we do some, this is where we initiate the conversation with the user. There is something wrong here. This will throw an error here. This will throw an error because we're trying to import from custom knowledge. But if you don't have this file, it will throw an error. So maybe we should put a check here. Right? Because we talked there's multiple ways to do this. One is with custom knowledge. You can also, one of the original versions of the files that I was working on was actually taking an input directly from the terminal, but then I later thought just taking the time to craft your custom knowledge here ahead of time would be more beneficial, because you can delete things and you can't do that in terminal. Like maybe you paste something in, you don't want this part, you can delete it, for example. So you can be really fine with it. That's for custom knowledge from URLs is automatically generated. Yeah. So we did say that we are, so when you're doing function calling, do try to implement a system like this, I guess, meaning you try to load the arguments with JSON.loads. If that fails, then do something else. Okay, you can still parse that argument, right? You can still try to find that using string methods and regex. Don't give up, because this is going to happen. If you use function calling enough times, you're going to run into it and you're just going to hit your head against the wall. I did that with autocoder 5, I think, because especially with JavaScript files, it would just, you know, it just was. Anyway, just keep that in mind. You can't do that. And this was actually very expensive the way I originally implemented it. But what we're doing is, see, we are when the message grows to 5 or more items, we are always reducing it to the first 3 message. Why the first 3 message? Because that's the system message, our question to ask it if it's ready, and its answer. So we always want to keep these ones. And then we are keeping the last 2. That's all we really, that's all the messages that we really need to keep. Why? Because it keeps rewriting. We don't want to keep this in the message history, because, you know, let's look. So I know I'm jumping from one thing to another, but look, this is the output if JSON.load works. This is the output if JSON.load doesn't work. But see, I extracted and saved it anyway. You can still use this, right? So look, it turns out we got JSON.load to work on one, and then the next one it failed. This usually just would have been an error, but because we wrapped it and try except, we still were able to extract the information. And the next one it failed, and the third one it failed, and the fourth one it didn't. Now I forgot what I was talking about. Oh yeah, so the first message would return this, first function call will return this, but then the fourth one will return this. We don't need to keep this still, right? Because we have it, right? So we dump it. We do that here. We say if the messages get long enough, more than 5, we want to keep the first 3 and the last 2. Then this loop ensures we don't exceed the length of the knowledge list. And we run this twice, because in this loop, we first append to the messages the knowledge, right? And then we make a call. Excuse me, we make a call, and if we need to, if it is time for us to make the call for an idea, then we also drop previous messages. Yeah, only if we, so sorry, only if we have more than 5, because we will keep the last 2, meaning we will keep the essential information still, because that will be in the last 2. Yeah, and also after the novel idea generation, we drop the last 2 messages, because we don't need that. We were just getting that. We don't need to feed the idea back to the GPT, but if you come up with a cool idea, you can feed it back. I hope you're seeing this. After the novel idea generation, I drop both the question to generate the idea generation plus the response. So that's it. If you have any questions, please. Otherwise, we'll end it. The code files for this is at Patreon. It's at the $9 tier. But maybe you might want to implement from scratch. Maybe you'll have a better idea. Here are some. See, this was my first attempt. So you can see in this first attempt, combined essential information extraction was first, and a novel idea boolean was second. If you do it like this, it will always generate. I couldn't get it not to generate combined essential information. See, this one takes a multi-line input. It creates the knowledge list, and then there's the content one. Anyway, but these were my old attempts. Oh yeah, how many tokens paper may use? Yeah, that's right. Papers, actually, I did a So the app that does this, let's take a look. So this is deployed at Railway. I have a video on this too. You can watch the video on the LLM summarizer. It's this one. The thumbnails could have been better. It's very busy. Anyway, the also GPT summaries do download every hour. See, download article PDF. And with that one, I actually limited the tokens to summarize article. So I do limit it to 15,000 tokens. But you know, if you do deal with papers, I just want to mention this. Look, there's something interesting. So if you go to a paper, you can save a lot of tokens by getting rid of this, getting rid of stuff. So all this is good, but towards the end, you're going to see references. Let me search for it. Yeah, references. Look, we are maybe 1/5 way. See, look at we're right here, and then there's a bunch of references. And sometimes after, so you don't need any of this. And sometimes after references, there's additional information, but I hardly doubt that's essential. Otherwise, they wouldn't put it after references. So, for example, here, see, I'm sanitized. This sanitized article text is actually dropping everything after references. So this automatically saves a couple of thousand tokens sometimes. So 15,000 tokens ends up being a lot of papers can fit into it, but if they're longer than that, I clip them anyway. So I'm trying to do a full summary of it with the LLM papers. For this, I'm using a function call too. See, it generates a summary, bullet points, and keywords. Oh, no, I guess I'm not using function calling. Interesting. I thought I did. Oh yeah, that's fine. Because I should have used function calling, because if I did use function calling, I could have this as a list and I could actually do all kinds of other cool stuff. Yeah, DSL, no problem. Thank you for watching. I really enjoyed this. Was a lot of fun. It was really challenging to sometimes, you know, you have an idea and to get it working is a bit of a requires some thinking and failing. Like one of the ways that I failed, I'll tell you, is if you look here real quick, this while loop was so much longer, and I was doing it completely backwards because I was actually making the call to get the knowledge. This was just entirely backwards. Maybe it's here. Look, see, look at that. This was something like the original loop, where I'm trying to check for whether I should make a novel idea generation call or not. And then this essentially didn't work. And I spent like 3-4 hours trying to get this to work. I added novel idea flag, Boolean. I added a bunch of other things. I couldn't. And then I said, you know what? Just redo it. A lot of times, just stepping away from it and doing it from scratch is a good idea. Look, and then I was able to squeeze it into 20 lines of code. You know, just the logic of when you're going to do this and when you're not going to do it, and how you're going to handle messages, which messages do you need for each circumstance, which ones you're supposed to drop, things like that. Anyway, thank you for watching again. You know, I do use the arXiv app. I use it myself, honestly, because I forget. Like, take a look at the function calling videos. This one is a lot of fun. The stress test. Anyway, I'm thinking of maybe turning this into a web app. If I do, I'll make a video on it. But thank you for watching, guys. Everybody. I mean, guys and gals. And take care. See you in the next one. Be safe. Be cool. Happy coding. Thank you, Shemaya. Shemaya. Take care.